Hello, my name is Azim Ganiala. On this session, I would like to present and introduce. We are gonna use CONTAM software. It's a software from. So this is the website of NIST. You can directly download software of CONTAM over here. So you can just click download. And then just right click on this link on the up, and then when you scroll up, you can just double click in next install, and it's open. Finished, you got it, and now this is the software you have to be shown. It's just a software about some schematic drawing. This drawing is not a schematic drawing. Okay. It doesn't mean that this is, for example, if this is 2 meters, this is 2 meters. No, it's just a simple drawing of some room. Okay. There's some room. And then you can zoom in or zoom out if you want, but okay, it's not so appropriate right now. I want to explain on how to use the software as a very simple simulation. So just imagine that if you have one single room, and with a view occupants inside, which is maybe you and your friend or your boyfriend's office room. Maybe there are 4 or 5 officers inside. So we are gonna simulate. We're gonna simulate about the simple office room, and if the room has supply air, there's some amount air maybe, and then extra air. So let's say in a very simple definition, the supply is highly equal with the exhaust. Let me repeat again. Now this is the CONTAM. This must be a CONTAM we are gonna use. So okay. So let's assume that we have a very simple room, very basic simple room like this. And then what we need to do right now is to define that this room means there is a zone. So you just double click. You just double click the zone, and then you give the name. And don't forget any kind of text inside of the CONTAM simulation. Space is not allowed. Okay, so please avoid any kind of space. So space like this, no. This is highly. Now you need to, for example, class room _1. So you should do like this. And then this, if you type like this, and this is not allowed, the system will be error. This see, blanks not permitted in it. So you need to be type like this, class room _1, for example, if you want to make some differentiation between these two rooms, because CONTAM is possible if you want to make a room that side by side like this. But if you want to do it, you forget how to do it. Yeah. Okay, now what you need to do right now is to define that the outside is the ambient. You just right click and click ambient. So that would determine that the outside is the ambient. So let's say the outside is the outdoor or outside, outdoor air. Yeah. And this is the room. So beside of the zone, so this is to determine this is the zone, some zone. And don't forget, please enter the number of floor area. Okay, no, skip the floor area. I want to tell you that very important that CONTAM, which derive from the mass balance equation, it highly dependent with the number of room value, not number of room area. No. So it highly dependent on on the room volume. So what CONTAM want to ask to you is a number of volume. So just input directly how much the room volume in your office. Because we now assuming that this room is an office room. So room volume, for example, yeah, 300 cubic meters, for example. And then floor area will be automatic because in CONTAM there is a default number where the room ceiling is 3 meters. Don't worry, maybe if we simulate in the CFD, for example, if we simulate in the CFD, we simulate the human acceleration rate and then how big the room is. Yeah, it has an impact, but in CONTAM, because CONTAM is a uniform calculation, so there is no meshing or something because this is a single equation, not not the boundary layer simulation like Navier-Stokes. No, this is not a simulation like that. This is a simulation of a single equation with iterative mode. So don't worry. The default of the room is 3 meters. So what CONTAM want to know is only for room volume. So if you have a room like this, maybe you know the number of room area. So don't forget to measure how high the ceiling is, and then you got the room volume numbers and input the room volume into here. And then the temperature, yeah, just assume the constant, maybe a variable, because in CONTAM, temperature is not simulated well, but it is possible to be as schedule level. If you want to make some schedule of the temperature. So that means that in CONTAM, temperature is not well simulated. Yes, maybe sometimes it affects the pressure, room barometric pressure, maybe, or because temperature here will affect the pressure, see, pressure. But I can show you that. Just tell it what it was. Okay. Just leave it like this. And for the contaminant, I will talk about this later. It will be automatic. And yes, okay. And then don't forget about the schedule. I will talk about this later because this is about the temperature schedule. That's why I said to you that temperature is not simulated, but it is become an input where the temperature is maybe scheduled level up, level down, depending on the real situation. Sometimes in the summer we have temperature 24 degrees Celsius, and maybe in the winter we have 21 degrees Celsius, maybe. So we can put some schedule in this part. Okay, but just keep it the important. So main important thing is the room volume. Okay? And how about the 20? I think, so let's assume that room volume is 60. If we have a room volume 60, maybe the floor area is 20. 20 is equal with 2 occupants inside it. Yeah, so maybe we will assume that 4 occupants, maybe, or 5. Room volume will be 150. Then the floor area must be 50. So let's just assume that we have room office with 50 meters square. Okay, and then just click OK, and then now let's talk about the airflow. You just easily right click and click flow path. Okay, don't forget, right click exactly on the line, and click flow path. Okay, if you okay, and then you can double click, you can just double click and then define the element. So what kind of element, what kind of airflow we want to define in here? You just forget about this here. It is blank because we don't fill any kind of element here yet. Now just click new element and then find the model of airflow you want to maybe okay, the most easy way for me to use is constant mass flow. Yeah, possibly constant volume flow is okay, but you know, sometimes the pressure is uh, dynamically moving. But then if we include the constant mass flow, then the the airflow, how much kilograms of air. So quantum mass flow, it's very easy as a theoretical. So just we use the quantum mass flow now, and then we, for example, if we want to assume that there is an airflow inside the room later is around 100 cubic to 100 cubic meter per hour. Okay, now we can click constant mass flow. And then what of the name of the fan? For example, electric fan, supply air. And then how much the flow rate you want to define. For example, I want to define cubic meter per hour. S means standard meter cubic per hour, standard cubic meter per hour. So, for example, 250, for example, 250 cubic meter per hour. Then now, we need to define the scheduling. Okay. Don't forget to define the flow path, the direction from ambient to classroom. If you click like this, that means maybe the airflow will come from the classroom to the ambient. So it must be exhaust air, not an intake air. But here we want to define as an intake air or supply air. So then we need to click OK. If we want to define the exhaust air, you can click wherever you want because all surrounding of this line is the output. So it doesn't mean that if you airflow come from here and then we worry if the air would directly strike into the exhaust air. No, it's okay because it's just a single equation simulation like it represents variables one more than one. Now you can click wherever you want and it will be different if you have a room like this. If you have another rooms next door of our office room, this room number 2, this is room number 3. If you put the flow path in over here means that some transfer air fan, that transfer the air from this room to this room. Okay, and then if you put the flow path like this, it means that the fan will transfer the air from here to here. Okay, so we look this again, and then so for the exhaust air, no matter you want, no matter important is if you want to put the flow path over here or over here. Okay, now we will define the flow path become the exhaust air. This new element. Or maybe possible if you want to use the same pen, okay. We can edit the fan name of the fan, electric fan. Okay, and then don't forget to define the flow path. So yes, from ambient to classroom. Oh no, this must be common intake room, intake air. So supply air. So it's false. We need to define it as from classroom to ambient. So now this fan, and then the fan direction will come from the classroom to ambient means exhaust. So then, this is multiplier. Multiplier means how many fans in this dot in this point. So if we define two, maybe there is two fan vertically. You can imagine that yes, vertically, and then the exhaust air will be if we put two like this, then the exhaust air will be twice of the flow rate you have defined. So now I just make a simple simulation. Multiply 1. Yes, and don't forget, I want to say that the flow rate here means the maximum. Okay, forget maximum flow rate. Then we can adjust or define this flow rate become dynamic by the schedule. But we'll talk about the schedule later. Now this is what you need is click OK. Now we have two fans inside the room. Is it right? You can imagine that this room will be a very simple room like this. And then there is two fans hitting to the window, supply air, and then it's just okay. So to make it balanced, sorry, this the air flow rate will be the same. And don't forget, you can understand it maybe a few times after you try this software, but some things you need is other flow path to make it balanced, because sometimes the fan work don't work in a very seriously same mass flow. Because there is human acceleration rate from the body, or other things maybe in the door, or maybe error calculation in the software. So I want to tell you that you need to new element, leakage area data, for example. Let's say because every room they have a door, of course, and then and then for example, how much the leakage of the the door behind, sorry, the door under close to the floor. For example, yeah, just put 60 or 50 or 100. You can measure it manual in your rooms. Okay, and skip it. It's default. Just click OK. And then schedule. I will talk about the schedule later. Now the flow path, whatever. You don't need to pay focus on here, because it will define automatically, or maybe this ambient question. It just dependent on how they will measure in the graphic. Okay, now time to input the exposure. Exposure means occupants. But before content gives us a warning about the, you must first define at least one species prior to creating an exposure element. Now it means that now we have to define the contaminant first. What contaminant means? To define how many percent of concentration of oxygen, how many percent of concentration of nitrogen, how many percent of concentration of carbon dioxide in the ambient. It's very fundamental. Now click data, click contaminant. Now we can define the contaminant over here. Don't make it confused. What we need to do is put the molar mass and default concentration as my experience. And don't forget to pick up the non-stress contaminants. Okay. Now for example, nitrogen. So how many percent of nitrogen in the ambient air? Zero, blah 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 blah. I forget that. Yeah. Okay. Molar mass is 28. is nitrogen. Okay, don't forget to pick up the tick over here. Just contaminant. Using simulation, yes, of course, we want to use it. Okay, now the default concentration of non-trans contaminant is 0, blah, 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 because of inflation. Now we can now this number will be up because of other contaminants. If you add more, and then make sure this number will become 1%. So now we need to add again. The 32, and 32, and many percent of constant. Yeah, for example. Okay. Yeah. Now, time to add one here. So I'll share to make it easy. And how many percent? Oh yeah, don't forget to change it, become ppm. Yeah. Okay, ppm. How much? For 14? Yeah. Yeah, okay. Let's assume that the default concentration of CO2 is 14. Wow. But then, okay, now it's going to, okay. So, you click zone contaminant. Now we can see that contaminant will be variable. Means moving depends on the how much the exposure inside the room and how many airflow to rewash the indoor air inside. Now so if we want to define the the ambient air inside the resume, we can strictly edit in here. But this material. Now, how can we add occupants? Right click wherever inside the room, and then exposure. Click on exposure. And double click to the bar. Okay, simple. How many occupants maximum inside? I would like to make it become number like 10, 100, 1,000, or 10,000, because now in schedule, if we, for example, if we put multiplier become 10, if we make the schedule become 0.4 or make a schedule 4%, sorry, 40%, it means how many occupants inside? 4 occupants. If we define the percentage of schedule 70%, it means that there are 7 people inside them. So to make it easy in the scheduling, just put the multiplier is become 10 or 100 or 1,000 or 10,000. So make it the multiply of the 10. So genetic contaminant, yes, CO2. Okay. Now they will ask how many how many generation of oxygen. Now human body doesn't generate oxygen, doesn't generate nitrogen, and human body do generate CO2. And then how many yeah, I would like to use, let's say 15 liters per hour. You can find it in some literature, because human body CO2 generation rate is very dynamic numbers. Depends on the metabolic rate, and then depends on the, sometimes it's related with the biological conditions. But let's say assume that in there is some literature, if occupants inside 1.2 metabolic rate inside the office room, yeah, and around 50. So let's say just assume that it will be a 15 liter per hour of CO2. Yeah, you can change it. And then so just click occupants. And tricky, really. Okay, If you want to define maybe the number of occupants in the room, then manually changing, we must define in this generation schedule. I'm lazy to explain the schedule because it will be on next topic. So, yep, thank you for watching. Please wait on the next episode.